How does reflection work in waves and sound? Imagine shouting in a canyon and hearing your voice bounce back to you. That's reflection happening with sound waves. But how exactly does this bouncing back work? Let's find out. When a wave, like a sound wave, hits a surface or boundary, it doesn't just stop. Instead, part of the wave bounces back into the original space. This bouncing back is called reflection. It applies to all kinds of waves, whether they are sound waves, light waves, or water waves. When a wave reaches a boundary between two different materials, some of it may pass through, but some will reflect it back. For sound, this is why you hear echoes when sound hits a distant wall or mountain. The law that explains how reflection works is called the law of reflection. It says that the angle at which the wave hits the surface, called the angle of incidence, is the same as the angle at which it bounces away, called the angle of reflection. Both angles are measured relative to an imaginary line called the normal, which is perpendicular to the surface. To picture it, think of a ball bouncing off a wall. If it hits the wall at a certain angle, it will bounce off at the same angle on the other side of the normal. This predictable behavior helps us understand many everyday phenomena. For example, when sound waves hit a hard surface like a wall, they reflected and travel back toward you, creating an echo. The type of surface matters a lot. Hard, smooth surfaces reflected sound well, making echoes clearer. Soft or uneven surfaces tend to absorb sound, reducing reflection and echo. Reflection can also change the wave's properties. Sometimes the reflected wave becomes quieter, which is called a decrease in amplitude. Other times, the wave can invert or change phase, meaning the wave flips upside down. For example, when sound reflects off a rigid surface, it can invert, which changes the phase of the wave. Understanding how reflection works helps explain how we hear echoes, how sound behaves in different rooms, and even how sonar technology works. Sonar sends out sound waves and detects their reflections to find objects underwater. So, in simple terms, reflection is the bouncing back of waves when they hit a boundary, and it follows the rule that the angle of incidence equals the angle of reflection. This principle is key to many natural and technological uses of waves.